As we continue in 4.3 to 4.5, our focus is going to be proving triangles are congruent a little bit more formally and using coordinate methods. Let's recall the 5 congruence postulates or theorems we use to prove triangles are congruent. Can you write the 5 down? Maybe you pause the video and see if you can remember them. So here they are. Did you get them right? Do you deserve applause? Well, there you go. I bet you did. Now let's talk about what is a proof. Well, last time we went through and proved triangles were congruent using one of these 5 postulates or theorems, but we did it informally. We just talked through and marked the pictures. Today we're going to talk more about a formal proof where we write everything down that we are marking in our pictures. So we want to make sure that whatever we say is true, we write it down. Write everything down that we're using to logically prove the triangles are congruent. So that means what we marked, what is congruent, and why. Why is it congruent? The what is congruent is going to be our statements. The reason why it is congruent we'll call our reasons. Now let's start with something that we're used to seeing. Given the coordinates of 2 triangles are triangle PVH, P, -4, 0, V, -1, -2, H, -4, -5, and triangle NQR, N, 0, 0, Q, 2, 3, and R, 5, 0. We need to prove that this makes triangle PVH congruent to triangle NQR. Let's graph the triangles on our coordinate plane first. Let's put these points on and label them as we go. And there's V, H, -4, -5. Okay, so that made triangle PVH and triangle NQR, N at 0, 0. Notice how I put the points, the names of the points as I plot them. And then I connect them. So how are we going to prove that these triangles are congruent? We're not given any information about which parts are congruent, but in a coordinate plane, we can find lengths of segments. So we can find these side lengths. Let's start with some of the ones that are easiest to find, like the ones that go right along the grid lines that are just vertical or horizontal, like PH. We can just count the blocks. P to H is 1, 2, 3, 4, 5 blocks. N to R is just 1, 2, 3, 4, 5 blocks. Since PH equals 5 and NR equals 5, we can say that segment PH is congruent to segment NR. Let's find the lengths of the other sides and mark the pictures as we go. So we said PH is congruent to NR. Let's put a congruent slash in there. Let's do the shorter ones next. How about PV? PV, we have 3 blocks over and 2 blocks down. So using our distance formula or Pythagorean theorem, we can say 3 squared and 2 squared. Square root of 3 squared plus 2 squared. And let's evaluate that. 9 plus 4 is 13, square root of 13. What side looks like it might be the same or congruent in the other triangle? Did you pick this one? Well, let's count. 1, 2, 3 blocks in one direction, 2 blocks in the other direction. That's looking promising. NQ. 3 squared plus 2 squared, and yep, it computes to the same thing, square root of 13. So these, PV and NQ, are congruent segments also because they have the same length. Now technically, we would say that these are congruent because the lengths were the same. So this is according to the definition of congruent segments. Since the lengths are equal, the segments are congruent. Let's not forget to mark our pictures that PV and NQ are congruent. One more set of sides to compute. VH. Let's count that one. 1, 2, 3, 1, 2, 3. So 3 squared plus 3 squared, 9 plus 9 for 18, square root of 18, or simplify it into 3 square roots of 2. VH, the last one here, is QR. So QR, and what do we count here? 3 and 3. So square root of 3 squared plus 3 squared. I have the same numbers, so I'm going to end up with the same answer. And again, because the lengths are the same, the segments will be congruent. Segment VH congruent to segment QR. So let's mark these sides congruent to these sides. So thinking of the postulates and theorems that help us prove triangles are congruent, what do we have here? 3 sides congruent to 3 sides. So now we can say these triangles are congruent because we have a pair of sides, another pair of sides, and a third pair of sides congruent. So we're going to finally say that triangle PVH is congruent to triangle NQR by the reason side, side, side postulate. Let's look at a couple that are a little bit different from that. So I'm giving you some information. Segment AB is parallel to segment CD, and angle A is congruent to angle C. Our goal is to prove that triangle ABD is congruent to triangle CDB. Now, information that's given to us is stuff that we get to use without having to think about why it's true. This is just given to us. Let's put it in the picture to help us figure out how to prove the triangles are congruent. Segment AB is parallel to segment CD. Well, we put the arrows to show parallel. Arrow and arrow for segment AB and segment CD. Angle A is congruent to angle C. Let's mark that in the picture. Now, what's this here? This T-chart, this T-table, is to help us organize our information and our thoughts. If we started by marking the stuff that was given, we do want to state that that was stuff that we marked in our picture. So we're going to state, even though it was given to us, what we put in our picture. But we don't have to think too much about that because, like I said, it was given to us. So the reason we were able to mark it in our picture, it was given information. They gave it to us. We didn't have to think of it. But now we do have to think of what we can mark in our picture from what we know about when we have parallel lines, for example. How can we use these parallel lines? Well, remember our zigzag shape? That gives us the alternate interior angles. There you go. We can draw our zigzag shape this way, and we get this angle congruent to this angle. Well, how do we name that angle that we just marked? A, B, D. We have to use the 3-letter name because angle B could be a variety of angles because B is the vertex of different ones. So let's use the 3-letter name. Angle ABD is congruent to angle CDB. CDB. And remember the name that we just used for these angles? Alternate interior angles. So we're going to put that in there as the reason that we knew that we could mark these congruent. What else do we know that's true about this picture? Well, how about this side that's used in both triangles, that shared side? We can mark that congruent to itself. Do you remember the reason for that? Well, let's write down what we're marking. Segment BD is congruent to itself. But how do we want to write it is the order that it's given in our statement. Segment BD is congruent to segment DB. Well, if it's a shared side, if it's the same exact segment, BD is BD, the reason? The reflexive property. Remember that one? Reflexive because it's like we're looking in the mirror. See the same thing when we look in a mirror. Now let's see what we have. Remember, if our goal is to prove the triangles are congruent, we want to think of one of our 5 postulates or theorem. Is it SSS, SAS, ASA, AAS, or HL? Well, do we have enough information yet? Let's take a look. In our triangles, we have 1, 2, 3 things marked, and those marks match in the other triangle. So we might have enough information. Let's focus on one of the triangles, maybe this one right here. And let's write down what we have marked. We have a side mark here, an angle mark here, and an angle mark here. This side is not marked with a congruent mark. This side is not marked with a congruent mark, and this angle is not marked with a congruent mark. So if I start maybe at this angle, I don't want to go this way. That passes through 2 x's, so I'm going to go this way. Angle, angle, side. So I do have enough information to say by angle, angle, side, these triangles are congruent. Triangle ABD is congruent to triangle CDB. See how it's just like what we did in class, but now we're writing down each piece of information as we go. Now, another way to see it without using the picture to see the AAS is look at this pair of angles is congruent. This is an A for angles. Look at this pair of angles congruent. This is an A for angles. And this is a pair of sides that's congruent. So this is an S. That's an angle, angle, side. Now, how do we know it's not angle, side, angle? Well, that's what the picture helps us do, is to determine which order is it. Let's take a look at one more briefly. Here's our given information, and here's what we want to prove. Let's start with marking our picture with the given information. Now, because we're given this information and we're gonna mark the picture, we know we can write that down in our proof as something we're using. We're not using because we had to think of it, we're using it because it was given to us. It's gonna help us to solve the problem and we didn't have to think of it. So let's write down all that given information and say why we can write it down. It was given. Now let's mark our picture. AB is congruent to DB. AB congruent to DB. That was marked for us too. C is the midpoint of AD. Well, if this is the midpoint, how do we show that? Midpoint means the middle. How do we show this is the middle? This side's congruent to this side. That's exactly it. So we're going to say segment AC is congruent to segment DC. We put a congruent slash here and a congruent slash through here. Those are congruent. Why? Because we know what midpoint means. Where do you find meanings? In the dictionary, where they give you definitions. The definition of midpoint is that it's a point that divides a segment into 2 congruent segments. 2 congruent segments. What else do we know is true from this picture? How about the shared side? It's congruent to itself. So segment BC is congruent to segment BC when it's congruent to itself, like looking in a mirror, the reflexive property. Do we have enough information yet to prove the triangle's congruent? Well, let's look at what's stated. There's a pair of sides, there's a pair of sides, and there's a pair of sides. No angles, so it must be side, side, side. If we look at the picture and we focus on one triangle, I see all 3 sides have a congruent mark. Side, side, side is what it must be. So now I can write down the thing we were supposed to prove. Triangle ABC is congruent to triangle DBC. Now take a few minutes to answer this question and write down your answer on your notes. Why do you think it's useful to write a 2-column proof? See you in class.